Let's talk about the problem of refreshing environment variables in pods. So here's the problem in Kubernetes. You have a pod that consumes something like a config map or a secret in an environment variable, and later you need to update whatever that source is. Could be a config map, could be a secret, doesn't matter. In this diagram, obviously, we're showing a secret. Now, normally, if you do that and you're consuming a secret as an environment variable in a pod, after you update that secret, the pods have no knowledge of the update that you just made. There's no API that goes and refreshes that. If you did this in a volume, that would be another story, but very commonly these things need to be consumed in an environment variable. Yet changing that source does not affect the downstream pods. They don't know anything about it. This is where platform teams really can use Kyverno to make their lives easier by installing automation that's defined as policy without having to write any code and maybe even eliminate some other tools in the process, maybe some of those being either bash scripts or maybe it's even handwork that's done. So in any case, what we want to see here is we have a secret that's being consumed in a deployment, and obviously that deployment is spawning pods. Now, I'm not showing a replica set here. We understand that that is an intermediary controller, but that the deployment is responsible for pods, and those pods are getting a secret. Now, Kyverno is going to watch that specific secret for any changes that may occur. If there is a change that's detected, perhaps by a user or by a process that makes no difference, Kyverno is going to see that. And in this case, it's going to be able to respond by finding the deployments that consume that secret as an environment variable, and it's going to annotate the deployment within the pod template area. And the effect that this is going to have is it's going to create a new rollout, which means that new pods are going to get spawned. And as a result of those new pods getting spawned, they will be able to pick up the changes that were made in the environment variable from the secret. And as that happens, it's going to, once the new pod is up and running, it's going to tear down the old pods. So the new pods with which we're left will have the new value from the modifications made to the secret. So let's flip over and show that. Let's go into our second one here. Now, the first thing that we need to do is we need to grant Kyverno some additional privileges. Kyverno is very security conscious and follows the principle of least privilege. One of the things that we need to be able to do here is to be able to modify or update deployments because we need to be able to annotate them. Kyverno makes this very easy because it uses role aggregation. So rather than going and changing cluster roles, which may be a pain because if you're deploying Kyverno, as many folks are with a GitOps tool, that involves making changes in Git, which may not necessarily be desirable. At least changing the existing cluster roles. We can introduce a new cluster role here that has the necessary labels which aggregate to the cluster role that's responsible and can get picked up by the Kyverno service account. So in this case, I'll just create an additional cluster role that will get aggregated and it will grant additional privileges that allows Kyverno to update deployments. So I've created that. And now let's take a look at our original secret. So I'm going to create a secret here, and this is an API token, you can think of it as, and here's the value that has that's in the clear up here. So 0628 is the value encoded as base 64, and this is going to be called blue secret, and it's going to go into our existing namespace. Now, I'm going to label this with kyverno.io/watch equals true. Now, this could be any label that you want, and in fact, you don't necessarily need a label, but for this demo, want to make this more dynamic in nature rather than focusing on a specific secret by name. So this will allow Kyverno to be able to watch it a little bit more easy without having to define or declare a specific resource. So in any case, we're going to create this secret as the first step. And now that we've created blue secret, we're going to create a deployment. And now this deployment, as you might have guessed, is going to consume in an environment variable that token. And so it's going to consume it in an environment variable named token, and it's going to fetch it from that blue secret that we just created in the key called token. And this is just a standard BusyBox pod. It's going to sit out there and sleep so that we could just want to make sure that the environment variable is consumed properly. So we'll go ahead and deploy this. So we've created the blue BusyBox deployment. Let's go ahead and get pods for this. And let's just check and make sure that the environment variable that it got is as expected. So you can see here, it's picking up our token environment variable, and we see the value 0628 is what I just showed a moment ago, and also our other endpoint environment variable. So that's all well and good. Now we want to get Kyverno in the picture because this is where it can really help us in our jobs. So this is what the policy is going to look like. Again, this is a cluster policy, which means that Kyverno is going to consider this across the entire cluster. And we're telling it to watch on secrets that have this kyverno.io/watch label. And again, this could be any label that you want. If you didn't want to have a label, you could certainly watch by name, but we want to watch by a label to make this a little bit more dynamic in nature because we may have multiple secrets that are consumed across multiple deployments in multiple namespaces. So we want to not tie us down. We're going to watch specifically for updates. We're not interested in creations of secrets. We're interested in when a secret gets updated because that's when Kyverno needs to snap into action. One of the abilities that Kyverno has, several admission controllers can do things like mutation, but what Kyverno can additionally do is mutate existing resources. And that's what we're defining here. In the target section, we're saying any existing deployment we're interested in any namespace. And now the magic is actually happening here where Kyverno is going to check that the name of the secret is mounted or consumed by this deployment. And if it's the same one that's consumed by it, and that's what this tag does here, then it is going to write an annotation. And you notice that this is in the pod template area. It's going to write an annotation that I've just called corp.org/random with an 8-character length random string. Kyverno has the ability to use a system called JamesPath, and within the JamesPath system that Kyverno consumes, there are many filters that we have written and provided specifically for Kyverno's use that aren't found in upstream JamesPath. And one of these allows you to very simply generate a random string based upon a composition of your design. And so you can see here with this regex, I'm just saying, give me a string that's 8 characters long, composed of numbers and lowercase letters. And it can be done just as simple as that. And we're going to put the value of that in this field called corp.org/random. So this is an annotation. And the effect that this is going to have is it's going to cause the deployment controller to see that change and understand that the actual state now has diverged from the desired state. And in response, it's going to create a new rollout, which is going to give us new pods. And those new pods should be able to fetch this updated secret. So let's go ahead and create this cluster policy in our cluster. And now that we've done that, now we want to change the secret. So we've already got pods that are out there running. Now we need to rotate our API token. And you can see above here, I've already generated the new base 64 for this, and the new value of our API token is going to end in 5 echo 2. So what we expect to have happen, and this is the same representation as the original secret, it's just we're modifying the value here. Kyverno should be able to watch this. And since it has the same label, Kyverno is going to see it, and it's going to find matching deployments that are in that namespace, and it's going to perform that annotation that I just mentioned a moment ago. So let's actually see what happens here. And now that we've done that, let's go back to our existing namespace and do a watch on pods. And okay, as we see here, we've got a new pod that as of 4 seconds ago is being spawned, and this one is going into a terminating state. So this is the new rollout that's taken place, and it's going to tear down the old one. So we should be able to get the environment variables in this pod, and hopefully with luck, we will see that Kyverno has done its job and the value of the new token environment variable has been updated to reflect the changes. And as you can see here, in fact, that has occurred. The new value of the token environment variable is 0.5 echo 2, 0.5 echo 2. That corresponds to our new value. So you can see in this case, there's some really nifty capabilities that you can use as a clustered operator, or if you're in a platform team already, this can really save you time and help alleviate some of the challenges that you might be faced with today. Or if that's not a challenge, this can give you some new ability that you didn't have today. In any case, this is an illustration of Kyverno's mutation capability, but its ability to mutate existing resources, not just resources that come in on the admission chain. Okay, so let's clean up here and we will move on to the next one. All right, so that's refreshing environment variables and pods. Hopefully you can kind of see this as a, hey, that's kind of a cool moment.